Hi OSLO users, this is the third in our series on Gaussian beams in our tutorial. In this video we're going to run Gaussian beam tracing. There's one page of instructions on what we're going to do. So if you'd like to capture it here before I start. So now we'll go back to OSLO, and this is at the point where I ended the last video here. So what we can do now is we have our lens and we're prepared to actually do our trace, our praxial Gaussian beam analysis, this ABCD analysis. So if you go to source, this is where we're going to define this source and run this command. So this asks you for beam specification and evaluation surface. We use the object and image surfaces. And so what we need to do is enter in parameters for a beam. So what we're going to use here is you actually define 2 of 4 of these parameters: a the waist size, the spot size, waist distance, and wavefront radius. Again, it's spot size. The waist size, by the way, equals the spot size if you are at the waist. So the waist size is what we're going to use here, and we're going to enter in 0.25. Now all of our units for our lens here are in millimeters, so this is in millimeters. 0.25, by the way, because we set it up as Heaney, it's got 0.6328, which is 632.8 nanometers here, and we have an m squared. We're going to assume perfect TEM00 mode, so m squared being 1, so it's a perfect Gaussian beam. And it's done some other calculations here too, things like Rayleigh range and divergence, so you can look at all the different setup parameters that it has here. And when we do this now, it's set up to go. I can hit print beam data in the text window, and when we do that, it gives us a set of parameters. And in this particular case, there are 2 solutions because it's a quadratic, but in the case like this, we only need to look at one because it turns out our beam waist was in our first location, so that made it where solution 1 is the only one that we need. So that's all we've got. If you look here, it shows a spot size of 0.25 millimeters in the object plane, and the waist size is 0.25. That means we've put the waist right there, so its waist distance is 0. Notice though that what happens is the waist distance to the image in the image plane shows clearly, because this minus sign, that we've already gone through the waist. In other words, there's this focal shift effect that it's actually got the beam waist that's inside the closer to the lens than what the praxial image plane is. But the praxial magnification here was that we would get 1/2. So it's true that from the object to the image plane, we've got a praxial magnification of minus 0.5, but the beam waist is actually a little bit smaller. So what we're getting here for our analysis does make sense along those lines, and that's what we're talking about with just go ahead and review the data in this window. The other thing you can do is you can hit this plot beam spot size, and you can do current graphics window, or you do the slider wheel design. We're doing the slider wheel design in this case just to show you, and you can see what it gives you is this beam propagation, and it might be a little bit hard to see, so I'll make this window nice and big. And what we can do is we can actually move through here, and you can look at the spot size. It's 0.25 at the waist at the object here, expanding upward until we get to the lens. I'm going ahead and sliding it here instead of clicking individually, and we come down to here, and here's the interesting part. We pass through the beam waist about, the beam waist size is 0.119. So we pass through the beam waist here, and it's actually occurring before we get to the praxial image plane, and it's about 21.8 millimeters closer. So this is actually a really nice graphical tool. It takes advantage of the pioneering of sliders in these types of programs. Really nice to use this to get an idea of what's going on. Now there's a couple of optional steps that I had put in here as well that you can do. So for one thing, let's say you look at it and you say, I really want to actually put a surface at the location of the beam waist. It's actually not hard to do that. We go here, we click in our surface data spreadsheet, and I go ahead in this case and I'm going to insert a surface before. And what we really need to do is we have a number here. This is the beauty of OSLO. This is one of the things that's just so awesome to use about it, is you can sit there with calculators and punching numbers in, but because of its beautifully designed spreadsheet system, it makes stuff like this so ridiculously easy to do. I can simply copy this. You could also use TH2 for this down if you really wanted to. And that is the total distance that I want here. And so actually I don't want to copy that. What I want to do is I want to take this cell and I want to make the negative of that cell. So if we look here, this is cell number D20. So I'm going to go minus D20 here. Now this of course is now no longer correctly set. We go here though, and now we simply add D20 to that. It's got that minus sign in there, which is why I'm adding D20 directly to it. And now the total distance here is still the same as it was before, but I've now inserted another surface, and it happens to be at the waist location. Makes it a little bit harder to view the system when you do that, unless you do some special things to focus in on the lens part of it. But that's okay. What we can do is we can run our same analysis again that we did before for the source, the ABCD. It still has the parameters in here. So I hit print beam, and notice now the waist distance is 0 at that location. So you may or may want to do that. It's an optional thing that you can do. And you can also do the plot beam spot size if you'd like. Again, the other thing that's nice to do sometimes in this is, let's say you want to come back later and you want to remember the things that you've done. The last step says, well, you might want to put some of those parameters into the system notes, and then you can come back and review. Some of these analyses, such as the source analysis for the paraxial beam, not all the numbers are necessarily saved. So if you're finding that it's a little frustrating and you want it to go along with that lens file, then please go ahead and use the notes for that.